The collision of the Milky Way and Andromeda, a galactic evolution. The universe is a vast and dynamic system, constantly evolving on a cosmic scale. One of the most captivating aspects of this evolution is the interaction between galaxies. The Milky Way and the Andromeda galaxy, two of the most massive galaxies in our local group, are currently on a collision course that will reshape their structures over the course of billions of years. Though the idea of galaxies colliding may sound like a cataclysmic event, it is a natural part of the universe's growth and development. In this essay, we will explore the evidence for the ongoing collision between the Milky Way and Andromeda, the processes involved, and the consequences of this monumental cosmic encounter. Evidence of the galactic collision. The first clue that the Milky Way and Andromeda galaxies are beginning to collide comes from the discovery of hypervelocity stars. These stars, often referred to as cosmic splinters, are traveling through space at immense speeds, fast enough to escape the gravitational pull of their home galaxies. To put this in perspective, these stars travel at speeds of around 1,000 kilometers per second, a velocity so great that they leave their galaxies behind entirely. This phenomenon suggests that gravitational forces between galaxies, particularly the Milky Way and Andromeda, are already interacting, creating an environment in which stars can be flung out into space at extreme velocities. But if the universe is expanding, with galaxies moving away from each other, why is Andromeda moving toward the Milky Way? The answer lies in the balance of gravitational forces. Although the universe's expansion pushes galaxies apart, the gravitational pull between the Milky Way and Andromeda is stronger than the force of expansion over relatively short distances. While the expansion of the universe affects galaxies that are separated by vast stretches of space, on the scale of tens of millions of parsecs, it has little influence on galaxies as close as the Milky Way and Andromeda. As a result, these two galaxies are not drifting apart, but are instead being drawn toward each other by their mutual gravity. The collision and merger process. The collision between the Milky Way and Andromeda will not be a singular, instantaneous event, but a complex and prolonged process. As the two galaxies draw closer, they will begin to pass through each other, causing tidal forces that will trigger intense star formation. The interaction will also eject stars from the newly forming system, sending them into distant regions of the galaxy or even intergalactic space. At around 5.1 billion years from now, the cores of the Milky Way and Andromeda will appear as bright lobes in the sky as the galaxies continue to lose energy through a process called dynamic friction. Dynamic friction occurs when the movement of stars and gas within the galaxies generates resistance, slowly draining their kinetic energy and causing the galaxies to merge. Eventually, the galactic cores will fully combine, forming a single massive elliptical galaxy. This new galaxy will be quite different from its progenitors. Instead of the elegant spiral arms of the Milky Way and Andromeda, the combined system will take on an elliptical shape as its stars settle into new orbits. By the time the merger is complete, approximately 7 billion years from now, our solar system could be flung to a remote corner of the new galaxy, or possibly even ejected into the vast expanse of intergalactic space. This transformation will mark the end of the Milky Way as we know it, and the beginning of a new chapter in galactic history. The role of collisions in galactic evolution. Galactic collisions are not unique to the Milky Way and Andromeda. In fact, they are a fundamental aspect of how galaxies evolve over time. The Milky Way has already experienced multiple interactions and mergers with smaller galaxies throughout its history. One prominent example is its ongoing interaction with the Sagittarius dwarf elliptical galaxy. As the Sagittarius galaxy is gradually absorbed by the Milky Way, it creates streams of stars and contributes to the growth of the Milky Way's halo, adding new material to its outer regions. However, the collision with Andromeda will be on a far larger scale than any previous galactic interaction. It will be the most dramatic event in the Milky Way's future, fundamentally reshaping the structure and composition of the galaxy. While smaller mergers have added to the Milky Way's mass, the collision with Andromeda will result in the complete fusion of two giant galaxies, leading to the formation of a new, much larger system. Conclusion. The future collision between the Milky Way and Andromeda galaxies is a testament to the dynamic and ever-changing nature of the universe. Far from being destructive, galactic collisions are part of the natural process of cosmic evolution, helping to shape galaxies over billions of years. The interaction between the Milky Way and Andromeda will trigger new bursts of star formation, scatter stars into new orbits, and ultimately result in the creation of a massive elliptical galaxy. Although this event lies far in the future, it provides a fascinating glimpse into the forces that govern our universe, reminding us that even on the grandest scales, change is a constant.